So we left off on worksheet 6A. We did a few problems and we skipped a couple. Specifically, I want to look at the bottom of the worksheet, example E. The instructions said they wanted you to find the line of symmetry, the vertex, and then notate whether the parabola opens up or down. And we're going to kind of discuss some other attributes as well. So first thing I noticed is this parabola is not technically in standard form. It's a little backwards. So if you'd like to rewrite it, you sure could. And on Friday, we discussed a couple of methods for how we could get this into vertex form. And one option was to do that modified completing the square. But as much as I love completing the square, I'm kind of looking through this question thinking, okay, I'd have to factor a 5 out of this part. So I'd already have a 6 over 5, and then I'd have to half that, and then I'd have to square that fraction. So while I could do completing the square, I think I'm not going to. Instead, we're going to use the formula for the line of symmetry, which is negative b over 2a. And we're going to do the rest of this question without a calculator. So I don't want to hear any clicking. Ready? Negative b would be opposite of this, so positive 6 over 2 times a, so 2 times 5 would be a 10. Now, 6/10, you can write it as 0.6, but because I have to do mental math, I'm actually going to keep it as a fraction. I'm going to keep it as 3/5. So what we just found, that is technically the axis of symmetry. X equals 3/5, or x equals 0.6 is the line that cuts through the vertex, which means when I ask you to identify your vertex, y'all just found the x value is 3/5. This is where it gets fun. I need you to channel your 11-year-old self. And you're going to do some fraction math here, guys. Ready? We're going to plug in a 3/5 to that function right there. So 5 times 3/5 squared minus 6 times 3/5. And then we're going to add it to 12. All right, here we go. Order of operations, you square that fraction first. So this is a 9/25. So you have 5 times 9/25. We're going to come back to that. Minus 18/5. Come on, pen. And then plus 12. So that first fraction, that 5 times 9/25. So travel back to 5th grade with me, guys. Remember cross-canceling? The 5 and the 25 can cross-cancel to a 1/5. So this fraction is really a 9/5 minus 18/5 plus, I'm not going to call 12 12 anymore, because when I add fractions I need common denominators. So that would be 60/5, 60 over 5. So what do we have here? 51 over 5? That was fun. What a great way to start your week. Happy Labor Day weekend, everybody. All right, 51/5. The good news is we don't have to graph that, so I don't really care about what that actually means. So I have axis of symmetry, I have vertex. Can you tell me if this parabola is opening up or down? Up. Why? Because the A is positive. Very good. Can you also give me an attribute about this parabola? Is it normal, is it thin, or is it wide? So you look at the coefficient, which is a 5, and it's thin. It's vertically stretched by a factor of 5, so it's pulling up all your y values times 5. So it's real. This is really skinny. Very thin parabola. Good news, we don't have to graph it. Moving on to the back. I think we left off at that one. So we're going to, I really enjoy these questions, but I'm a math teacher, so I'm already weird. But these are like puzzles, so they're going to give you clues, and your job is to find a formula. So when they give you a clue about a vertex, that is them telling you about your h and your k. And then when I give you a random ordered pair on a function, that is them telling you about x and y. So if you have h and k and x and y, and I think about all the formulas that I have for parabolas, I think vertex form would be a great way to start. So vertex form is y equals a, parenthesis, x minus h, that quantity squared, plus k. And then here we just place our numbers where they belong. So, who is the y-coordinate of the random point that I gave you? 7. You do not know a yet. That's what we're going to try to find. Who is the x-coordinate for the random point I gave you? 0. Good. Who is the h-coordinate of your vertex? It is a -1, so using our 2/ rule, it does one of those. Yep, yep. And then plus k. Who is the k? 4. Very good. All right, so, oh my goodness. It's not going to work. Here we go. Plus 4. So a little bit of simplifying here, guys. 1 squared is still going to be a 1. So this whole term here is kind of boring. It's just 1a or a. So you have 7 equals a plus 4. What is your a value? 3. Yep. And after all that work, you'd probably figure you're done, right? You're not. So now you're going to take the a and then the vertex, which does not change for this parabola. And you're going to plug in those 3 pieces, the a, the h, and the k. So your function is y equals 3 x plus 1 quantity squared plus 4. So that clue of x and y from the beginning, the 0, 7, they're only using that clue so you can see the relationship between the parabola's points. Once you use that to find a, you throw that clue away. It's gone. I think we discussed this on Friday, but sometimes children get crafty and they're like, you know, I was pretty sure the a value was 3, Bruzo, so I just put down a 3. And that's not going to cut it on your test for a couple of reasons. The first reason being I need to see your method and your work. But the main reason is your a value on your test will very rarely be something nice. Like instead of, oh, I think it looks like a 1, it's going to be like 12 over 13, like something crazy that you would never guess, okay? So you have to go through your math, and I apologize for that. All right, letter E, vertex at 2, 5, and then an ordered pair of 4, 6. So this vertex being at 2, 5, that is your h and k. And then the ordered pair is your x, y. So same formula. Who is the y coordinate from the point? 6, thank you. Equals, I don't know a. The x was a 4. And then you're subtracting the h. Who is the h clue? 2, thank you. Now, very common mistake happens right here. Kids forget that this quantity is squared. Because when it's a 1, it doesn't matter, but this time it will matter. And then plus your k value, which is a 5. So, let's think about what we have here, guys. This is 4 minus 2, which is 2, but then you're squaring that quantity. So this is really a 4 times a plus 5. All right, let's solve. Subtracting a 5 over, we get 1 equals 4a. And then dividing both sides by 4. Y'all just found out that your a value is a 1/4. Which means now you can finally give me my answer. Y equals 1/4. X minus h, quantity squared, don't forget your squared, plus k, which is 5. So, like I said, I enjoy those problems. I think they're fun. But we all know I'm a little weird, so whatever. All right, questions so far. So now we're going to get friendly with our calculator. So this is a case where we're all coming in from different classrooms. Some Algebra 2 teachers really love using the graphing calculator, and some of them did not. We are going to use it a ton this year. So remember, I have some you can check out if you need to check one out for home. But we need to help each other out, and if you need me to slow down on a step or go back a step, throw a hand in the air. From here on out, we're going to be all in the graphing calculator, and we're going to be using a lot of different menus within it. So what we're going to do is after we kind of go through a question, because these are your notes, we've got to go back and we have to like write down what button did you press, because you can't really take notes on your graphing calculator. It doesn't really work that way. But that would be awesome if you could. The future. All right, right? So, from the top of a building, a toy rocket is shot upward with an initial velocity of 132 feet per second. The formula, the height of a rocket is given above the ground at time t. Okay, very cool. At t equals 0, that's when the rocket left the launch pad. Then they give you a formula. So a really quick aside for us. This is a formula that you are going to see a lot of in this class and possibly in physics. But in physics, I think they give you a little different formula. And that looks very much like a science formula, doesn't it? They love subscripts in science. So h of t is just function notation for the position of a launched, thrown, kicked, something object. And we're going to go through these problems soon, again. And we're also going to talk about what are called parametric equations soon, next semester. So we'll come back to this concept. However, notice that negative 16 kept showing up in your Algebra 2 problems over and over and over again. Do you remember what that was? And why it kept showing up? I heard it. I heard gravity. So negative 16 is the acceleration due to gravity in feet per second squared. So it's the acceleration of gravity in feet per second squared. So when you move on to your physics course, they often don't measure in feet. That's only America. So everybody else measures in meters. So they have a different coefficient. They have, I think it's negative 9.8. Yeah.
Oh, yeah.
Yeah. So it's same idea. It's acceleration due to gravity measured in meters per second squared. So in math and in science, when you have a subscript of a 0 or an O, depending on who you're asking, does anyone know what that little subscript means? Just the subscript part? It is the initial. So in this case, v sub naught, we call that sub naught in math. How fun. This is the initial velocity. And then h sub naught would be the initial height. And just like in Algebra 2, these problems are going to seem pretty stinking lame. Like I remember an Algebra 2 question about a kid throwing an orange up into the air. Like, why would you calculate that? So, anywho, these are also going to be lame for a while. Eventually they'll get more exciting, but think about this, guys. If you were to hit a baseball, the angle that you hit it at makes a difference in the launch. The speed at which you hit it makes a difference in the launch. The height at which you hit it makes a difference in the launch. So all of those components are working together to create the parametric equation, essentially, but for now it's a quadratic equation, and there's some good stuff going on here. So, I digress. This is one of my favorite topics. When we get to parametric equations, you guys are going to get a big old lesson on sports science. How fun will that be? All right, however, this problem is not exciting. We're launching a toy rocket off of a roof of a building. Now, first of all, don't do this. It's not safe. What comes up? Yeah, someone's going to get hit by a rocket, guys. Don't do this. So anyways, this rocket was launched with an initial velocity of 132 feet per second. Cool. The first question says, how tall is the building? So they already gave you your function. And remember, we decided that this middle number is initial velocity, but that last number is the initial height. So this question's a little misleading because we're assuming we're launching the rocket off of a pad that's literally at the top of the building, which probably isn't true. But just go with me, guys. This number right here is 60 feet. So that means the original launch height is 60. For the rest of the questions, we're going to rely on our technology. So, on your calculator, he does not accept variables in this mode other than x. So when I go to graph in y equals, I need you guys to graph y equals negative 16 x squared plus 132x plus 60. But don't graph it yet because we're going to play with the window. All right, get that typed in. Now, one thing to check, your plots that we had turned on when we did scatter plot, make sure they are turned off. So if any of those plots are highlighted and dark, you need to de-emphasize them by going up, hitting enter, and then coming back down. Yes? We got it? Okay. Make sure your function's typed in appropriately. Now, our window has not been set up yet, and being in PreCalc, I do expect you guys to be able to set up a window manually. I know some of us are big fans of Zoom Fit. Zoom Fit has its limitations. There are times when I use Zoom Fit. This isn't one of them, though. Because I do know a little bit something about launching toy rockets off of a roof. That's not true. I actually don't know anything. But I do have a little bit of common sense. That's not really true either. I have very, very little common sense. But guys, you're launching a rocket, a toy rocket. How long do you think that rocket will be in the air? Because right now I have my time, which is x, going from negative 10 seconds to 10 seconds. So my first question, do I need to go all the way back to negative 10 seconds? No, Michael J. Fox. You get it? Back to the Future reference. Come on, come on. What are you, children? All right, so let's start time at 0. Like, who's Michael J. Fox? All right, 0. And then I don't really know that much about this particular toy rocket, but I do know that I just did this problem last hour, and 10 seconds is good enough, okay? So 10 seconds is a good limit for our time. Now, let's talk about y, which is measuring the height. I know this sounds weird, but I'm actually okay with your minimum height being at -10, because that's 10 feet underground, and there's a question coming up where I want to know when it hits the ground, so I want a little bit of a window below it. But for maximum height, I mean, I don't really know, but I know that the rocket started at 60 feet up in the air, and then it was launched, so it's going to go pretty high. Anyone have a guess? Bigger. Go with it. 400. Again, thank you, first hour, for doing that problem with me. So why maximum 400? Now in first hour, we didn't know that. So we had to, like, someone first guessed 300. And then when we looked at the graph, we went, uh-oh, wah-wah, not high enough. So then we just went to 400. Because go big or go home in that moment. Ready? Graph. Oh, that's beautiful. So the first question does ask you to find the height of the rocket at 3 seconds. Is that the first question? Okay. So there's a couple of ways we can do that. You can go to your table. You can set up your table to be in a particular mode, and that's fine. But there's a much quicker way, guys. If you just hit trace, it's going to pull up the cursor on your function. And then if you want x equals 3, you just type 3 and then hit enter. And then kablam! It shows you what happens at x equals 3. So what is the height of the rocket? With a label, please. 312 feet. Very good. What's my next question? At 8 seconds. I don't know, but I bet we're about to find out. So we're going to use that same technique. The cursor's actually already pulled up, so you can just type in 8, but you can still hit trace. It's fine. 92 feet, I heard. Thank you. So those two questions were basically the same technique. So if I'm writing myself some notes for later about how did I find that number, I hit the trace key to pull up the cursor, and then I just typed x equals whatever the time was, and then boom, we had our answer. So then my next problem says, when does the rocket hit the ground? So when I look at my graph, I got to think about this like an algebra student. This right here is where the rocket hits the ground. So what is that called in a function or a graph when it comes down and crosses the x-axis? It's got a bunch of names. It's called a 0, it's called an x-intercept, it's called a solution. So for my calculator to find it, we have to go to what's called the calc menu, so second trace this time. And then he called it a 0, so which command here makes sense? A 0 command, which is number 2. And this is where you have to follow the directions. It says left bound question mark. He wants to know if you currently have your cursor slightly to the left of that x-intercept. And mine is. So I'm going to hit enter by saying, that's how you say yes. You hit enter. Now in the cool new ones, they show you this cool line that pops up. I love that. Now it's the directions change. It says, are you to the right of it? No, I am not. I have to get to the right of it. So you can either use your right arrow and scroll. My emulator has a really bad lag, so instead of scrolling, I'm just going to jump to a number that I know is past the x-intercept. So like I know if I go to x equals 9, I'm going to be past it. So I'm just going to type 9, enter, and then it jumps over there. You guys can use that as a shortcut. So instead of scrolling left and right, you can jump left and right. And then the last thing it says, is this where you're looking? You see those two lines? Your x-intercept should be in the middle of them. So yes, it is. So I say enter. Let's go to the 100th place. It hits the ground at 8.68 seconds. Of course you did. That's so you. It's just short. Yes, it is short. I need to know to the 100th of a second, sir. This is critical information. Uh-huh. Alright. So on my notes, I'm going to write down what we did there. It was, I already forgot, 8.68 seconds. So we found that by going to, this time we went to second trace, which is the calc menu. And then we chose number 2, which is the 0 finder. Now it's going to ask me some questions about what is essentially the vertex. It says, at what time did the rocket reach its maximum height? And then it's going to ask me, what is that maximum height? So two separate questions. So let's go find the top of that parabola, also known as the vertex. What would you call this vertex in reference to your options in that calc menu? He is the maximum. Very good. If it's the top of a parabola, it's the maximum. So choose number 4. And then this time, when it says left bound, right bound, they're referring to that maximum. So you need to drag your cursor over here to the left of it. For me, I'm going to hop to the left. So give me an X that you can tell is definitely to the left of that maximum. Well, 0's way left. I'm going to go a little closer. I'm going to go 3. So like here's X equals 3. Definitely to the left. Boom. And then you either need to scroll or hop to something that's to the right of the maximum. So I'm going to go like 6. So I know the max is between X equals 3 and X equals 6, but let's figure out when. So which one of those represents the time? The X, good. So the maximum is reached at 4.13 seconds. That's the next question. But what was the actual height? 332.25? All right. Feet. So writing myself some notes here. We found these two components of the question by finding the vertex, which was second trace again, which is the calc menu. But this time we chose maximum. Was that number 4? I think it was. Yes. Oh, and I kept forgetting to do this. You guys are supposed to sketch your little picture here. But then remember how we came up with the window with a little bit of help from first hour? We do expect you to be able to come up with an appropriate window. So last hour someone asked me, can I just do zoom fit? And we talked about the limitations of zoom fit. The other thing I don't want to see is that when you tell me your X window goes from 0.174 to 11.389, like that's a weird window, guys. Like talk like a human and round that to a more appropriate set of numbers if you choose to do zoom fit, please. So either way, our window went from 0 to 10 for the X's, and then for the height it went from -10 to 400. And then you had this beautiful picture, right? Oh, that's not even close. All right. Yeah, look like that. Yeah, right? Exactly like that. That's exactly what it looked like. That was super ugly, sorry. All right, we have one more question though. It says, at what times was the rocket exactly 300? Now notice the pluralization on that. I'm going to give you a quick technique for finding that answer. Go back to your function. Go back to y equals. I want you to create a second function, y2. Call it 300. So you're going to have a horizontal line cutting through at 300 feet, and you're going to see, hopefully, 2 places where this happened. Boom. So they want to know, when did it hit a height of 300? So apparently on the way up, the rocket hit 300, and then on the way down as well. How do you find where those 2 lines cross? What's that called? Intersection. Very good. So go to your calc menu. Choose Intersect, which is number 5. And then this one is really easy. You just hit enter. So first curve, yes, enter. Is this your second curve? Yes, enter. And then when it says guess, he's going to go to the closest intersection point. So whoever it's closest to, that's the one it's going to find. So when I hit enter right now, he's going to default to this intersection point over here. And that happened at 5.54 seconds. So write that down. That's one of my answers. All right, so we need to find the second intersection point now. So pull up that command again. So second trace, intersect, which is number 5. And then when it says first curve and second curve, that's the same. But when it says guess, I need you to get closer to the other intersection point. Otherwise, it's going to keep finding that same one again. So I'm going to hop. It's pretty close to 2, so I'm just going to type a 2. All right, 2.71 seconds. Okay, so jot both of those answers down. So this guy right here was 2.71 seconds, and was it 5.54?
Yes.
Okay. And then remember, you're writing yourself notes about how you found that. So in Y2, you put a 300, and then you went to second trace, and you chose number 5, which was intersection, or intersect, I think it's called. All right. So far, so good. Don't put that calculator away because we're about to use it a whole bunch more. Can you find worksheet 8? So these next few questions that we do, they are going to be non-application questions. So I'm asking you to solve just regular old quadratics. They have no application to them. So basically it's a backup technique for solving using technology, which I love using technology because that's what you would do in the real world. Like, guys, I hate to break it to you, no one whips out the quadratic formula to solve real life math problems. I'm sorry. And I know you're like, why are you making me do it? Well, because you have a lot of steps to get there, guys. We got a lot of college to go still. But like, someone had to program the computer to do the quadratic formula, right? So let that someone be you. So on worksheet 8, we're going to discuss how to use our friend the calculator to find solutions. This is a great technique for when you're on a standardized test and you're just in a jam and you can't figure it out. Or if you're like a math team kid and you have some crazy problem and you just need to have a little hand up, this is a good one. If you are just trying to check your answer because you just have no clue what to do, good technique. And actually there will be a moment in your life where I actually ask you to, quote, cheat and use your technology to find the answer. It is a technique. I love this technique, but there are some limitations. You cannot find complex solutions with technology, at least not this technology. It gives decimal answers. So if your answer is like -5 plus and minus the square root of 37 over 10, there's no nice way to say that, so your calculator is going to give you an estimate. So yes, there's limitations, but it's a nice backup. So when I look at number 1, the first technique that we're going to be using is, they're both on your calculator, but this is using the intersect method, the one that we just got done doing. So what I want you to do is take one side of your equation and put that into y1, and then the other side of your equation, type that into y2. And we will have to talk about the window in a second, so don't bother looking at the graph quite yet. And please be careful about negative sign versus subtraction sign. A lot of kids get a little happy when they're typing that. All right, I forgot what the rest of the function was. -1/2 x plus 2. Oh, x squared, yes. And then it's just plus 2? Cool. Now, don't hit graph, because remember, our window was set up by us for that stupid rocket problem. Oh, sorry, that was rude. It's not stupid. It's totally appropriate for your life. Right. So offend Mrs. Hoffbauer because I called her problem stupid. I'm sorry. This question has no context. And because it's just an algebra question, usually the answers come out pretty close to like standard window looking. So to get back to our standard window of -10 to 10, just hit zoom 6. And in all likelihood, this is going to work. And it does. Do you see 2 places where your functions are crossing? Excellent. So your job is to find those 2 places. Now you're going to find XY ordered pairs, but which part of the ordered pairs are your actual solutions? Do you want the X or the Y when you solve a question? You want X. Like, think about quadratic formula. X equals blah. So you're going to give me the X values to both of these by using intersect. So second trace, choose intersect. And remember, guys, he's going to find the one that's closest to him. So right now I'm finding this guy first. So apparently that solution is 2. Nice. Let's go find the other one. So pull up the intersect command again. But before you hit enter on that third one where it says guess, you either need to scroll or hop so you're closer to the other one. I'm going to hop. How about we go -4? Oh, good guess, Abruzzo. You win. I may have already answered this an hour ago. I was cheating. My bad. So, we just found 2 solutions, guys. That was cool. Obviously a lot easier than like putting it in standard form and factoring it, and obviously easier than using quadratic formula, and definitely easier than completing the square. So then I know your next thing in your brain is, why won't she let me do this for all of them? Well, because we have to know all the techniques. You won't always be able to use a calculator, and not all the answers are nice. I mean, think about the ugly quadratics we've had over the last week. There's some nasty quadratics out there. All right, this next one is... Oops, wrong file. Similar technique, same technique, similar question. If you could please get one side into y1, and then the other side into y2. And I forgot exactly what it looks like, but it kind of looks like a spider. Kind of looks like, you know, one of these. Spider with half the legs, I guess. It looks like that. So I'm going to pause the video so I can help my kids here. All right, class, what'd you find for your 2 solutions? X equals 2 and -2. Very nice. Now, in all likelihood, solving that one algebraically probably would have been faster, but whatever. Technology is great too. All right, let's try another technique. Still using a calculator. This time, you would put your function into some version of standard form. So basically, you need to get everything to one side of your function and type that into y1. And that's it. So type that in, and then let's go look at what we have. I forgot what the function was. 7x squared. Thank you. Thank you. Now notice we've only typed one function in, so all we're seeing is a parabola. And if I want to know where the solutions to any function are, a solution is defined by a few ways, but it's where where y equals 0, where the function equals 0. So it's where it crosses the x-axis. So think about your calculator's language. What does he call these? Zeros. Your job is to find the 2 zeros. So how does my calculator find zeros? You go to calc, and you choose the 0 command. So this is where my technology fails me a little, because it's got that horrible lag. So if I'm trying to find this x-intercept right here, I can see, I'm going to take a guess that it's around -2, but in order to find it exactly, I have to go first a little bit to the left of -2. So I'm going to go to -3. And then it says right bound, so I got to go a little bit to the right of it. So I'm going to go to -1. And then, yes, it's in the middle of those two. So when I hit enter, it's going to do some calculus, and it's going to come out with -2.05. That is it is still rounded, but that's a pretty accurate x-intercept or solution to that quadratic. Now notice I said rounded, so it's not accurate. If I needed an exact answer, that would not cut it. I'd have to use another method. Here's what's happening, guys. Most common mistakes on that technique. First mistake, dyslexics. We don't know our left from right. Whoops. So it says left bound, and what do? I go right. So it's going to give you an error message when that happens. The other mistake that happens a lot is when you go left bound and then you go right bound, you're giving it first, it depends on what the function's doing, increasing or decreasing, but it's going to give you a positive function value and then a negative function value on the other side. So in doing so, your calculator then proceeds to do calculus because it understands that theorem. But if you give it, like, for instance, 2 positive values, like you scrolled too far, we've all done this back in Algebra 2 where we went too far, and then it said error, no sign change, that's the problem. It's not getting a positive and a negative value, so it can't do its theorem, right? So that's that method. And then you do the same thing for the other intercept. So second trace, 0, which is number 2 in the list. Now, left bound for this guy, I'm just going to jump to x equals 0. And then I'm going to go to x equals 2 for the right bound. And you can't really see the other line, but it is there. And then enter 1.05. Sounds good. I mean, we've done that a lot. We do that a lot in Algebra 2, that method. But I don't know about you. I like the intersecting method better. So can you think of a way that I could change the problem we just did to be an intersecting method? Yeah. What if you went to y equals and you made the second function just 0? It's going to graph a line at 0, and you can still do intersect, intersect. I'm just throwing that out there, okay? Do what you want. I don't care which method you utilize. I just need you to pick one and go with it and be effective at it. So you guys now have part of Worksheet 9 that you can do. The front of Worksheet 9, I think there's problems that are circled. If you need to check out a calculator, you got to come see me. Tomorrow we're going to finish up the notes for here. We have some applications on the back, and then I'm done teaching you about quadratics for a while, so that's exciting. All right.